Hi everyone, today we're going to take a look at lesson 6-1, operations on functions. Some one word you might hear today is going to be composition of functions. That is something new we'll take a look at today. Operations on functions is fairly similar to polynomial operations with polynomials. The only difference is we might reference it as f of g or f of x or g of x. And so it might be looked a little different. So f plus g of x just means to add the two functions of f and g. Same thing with subtraction, multiplication, division. The setup kind of just tells you what to do. Pretty much, it's just to save us time in writing. So this isn't saying to multiply. This is just saying the parentheses. This is in function notation, which we viewed back at the start of the school year. So do take a moment to go ahead and copy this down. Pause the video as needed. So we're going to take a look here at f of x is 3x squared plus 7x, and g of x is 2x squared minus x minus 1. And it says find f plus g of x. So all that means is we're going to add the two functions. That's it. Nothing weird, nothing special. We're just adding the two functions. So we're going to combine like terms. And when we do that, we get 5x squared plus 6x minus 1. And we would be done. So next it says to go ahead and find f minus g of x. So we're just going to subtract the two functions. So we're going to subtract like terms. And when we do that, we get x squared plus 8x plus 1. So do notice that the minus 1 becomes a positive 1 because we distribute this negative. So 0 minus negative 1 gets us positive 1. All right, go ahead and pause the video to find f plus g of x. All right, by doing f plus g of x, we should know, I know I have 2 plus 3 is 5. As a reminder, when we combine like terms, we do not change the exponents. So with that, I know I cross out d. And then 2 minus 4 is negative 2, so my answer is going to be A. Next, we want to find f minus g of x. So I'm going to do 2 minus 3 is negative 1, so that crosses out B. 5 minus 3 is 2, so that's a positive 2, that's all the same. And 2 minus negative 4 is positive 6, so my answer is D. All right, our next example is that we're going to take a look at multiplication and dividing. So we have f times g of x. So we're just going to multiply our two functions. So we have 3x squared minus 2x plus 1 times x minus 4. So we can use distributive property. You can use box property. You could do pretty much distributive or box is probably what I would do. It's just a different way of seeing it. So when we multiply everything together, we're going to get 3x cubed minus 12x squared minus 2x squared plus 8x plus x minus 4. And when we combine like terms, we get 3x cubed minus 14x squared plus 9x minus 4. Next, we have find f over g of x. So we have division of polynomials. One of the things here would be I would check and see if this is factorable. It's not. I'm just going to leave it as is. In this case, there's nothing left for me to do other than to say that x can't be 4 because we can't have 0 in the denominator. But people tend to get scared of the division one, but generally it tends to be one of the easier ones just because we're not able to do as much with it. If you factor it, you would cross out like terms or like factors, I mean. And I go over how 0 can't be in the denominator. All right, so go ahead and pause the video to try f times g of x with what's given. All right, you should get c, 2x cubed plus 7x squared plus 5x minus 2. Go ahead and do 2x squared plus 3x minus 1 for f of x, and g of x is x plus 2. Find f over g of x. Again, pause the video as needed. With this one, you should get b because x cannot be negative 2. If I plug in negative 2, I get 0 in the denominator. But 2x squared plus 3x minus 1 and x plus 2 don't have any common factors. We're going to head and go over the composition of functions, and this is just us plugging in or substituting an expression into a function. So f of g of x is one way we would say this, g of f of x. And that's, so when you see it, sometimes people just say fog because this is just saying f of g, and that just means to plug g of x in as for every x you see in f. And what they're doing here is if the domain of g, you get the range of g now becomes the domain of f, which is then the range of f, which is a little confusing sometimes. So if f of x is given as a list of coordinate points, find f of g of x. There's a huge ant in here. Okay. So that means f of g of 7, so f of 0, because g of 7, I would go here, and I see 0, so now I want f of 0, which is negative 1. And we just keep following this pattern. And so we now have a new list of coordinate points. That was a big ant, but okay. And then to do g of f, we would do the same thing, only in the opposite route. Notice though that g of f of 2 is undefined because there is no g of 6. So you're not always going to have the same amount of coordinate points. Sorry about that. That was a big hand. So we're going to do f of g of x and g of f of x using expressions. So we have 3x squared minus x plus 4, and g of x is 2x minus 1. So f of g is just plugging 2x minus 1 for every x I see in f. So that would mean that my x squared is now 2x minus 1 squared. The minus x is just 2x minus 1, and so on. So we would go ahead and simplify, combine like terms, and get 12x squared minus 14x plus 8. And this time we're going to do the exact same thing for g of f of x. So everywhere I see an x and g, I would put what my original f of x was. So we're going to do 2 times 3x squared minus x plus 4. And simplify and get 6x squared plus 2x plus 7. Oh, there was an ant. Oh, can't do it. So those are our 2 answers. Pause the video and then unpause to check your answer. You should get A. Pause the video and then unpause when you're ready to check your answer. And you should get C. Moving on to our real-world examples. We have here Hector has $100 deducted from his paycheck for retirement. He can have this deduction taken before state taxes are applied, which reduces his taxable income. His state income tax is 4%. If Hector earns $1,500 every pay period, find the difference in his net income if he has the retirement deduction taken before or after state taxes. So we're gonna have before and after, so 100 is for retirement. So if Hector has his retirement deducted before taxes, then uses his net income is represented by T of R, which is of 1,500, which is T of 1,400, which gets us 1,344. If he has it deducted after he does taxes, we're going to do the same thing, R of 1,440. We get 1,340. So the difference here is about $4. It's $4. He has $4 more to spend after taxes and after the deduction if he does the retirement deduction before he does tax. Pause the video and then check your work. You are going to get B. And that is the end of our lesson. I will see you next time.